Hi, welcome to Math 150. This first lecture will be on statistics terminology. A sample statistic or a statistic is a summary number such as a sample mean, sample proportion, used to estimate corresponding population parameters such as a population mean or population proportion. So here's an example. In a sample of several thousand voters in June of 2020, the proportion favoring Biden was 52% compared to Trump's 44%. And we can use these sample proportions as estimates of the proportions favoring Biden compared to Trump in the entire population of millions of voters. Each voter polled would be an observational unit or an observation or a case. And in the above example, a voter's preference is a categorical or qualitative variable. Trump and Biden are not numbers. If the pollster asks a voter who do you prefer, Trump or Biden, those are not numerical answers. They're names of candidates. So this is not a numerical variable. But we can get numbers if we add up the voters' preferences. Then we'll get numbers. The pollster also asks for the ages of voters polled. So if we ask, well, what is your age? Well, that's a number. So that would be a numerical variable, or also called a quantitative or measurement variable. The above poll found that Biden had an even wider lead over Trump among younger voters. So in this context, the age of the voter can be considered an explanatory variable or an independent variable because the age happens no matter what. It's not going to be affected by something, but it could affect another variable. So the age would be an explanatory or independent variable, and the voter's preference would be a response or a dependent variable. In some cases, the independent variable may cause or affect the dependent variable, but cause is often hard to prove. Income could be considered to be a third or lurking or confounding variable because income was not reported and may be another variable that may affect voter preference. One of the biggest challenges in polling is to choose a representative sample. And the way the sample is chosen can make a big difference in the outcome of the poll. A famous example is a 1948 poll of voters selected from telephone books predicted Dewey, a Republican, would beat Truman, a Democrat, in the presidential election. In fact, Truman beat Dewey. The problem was that in 1948, the people who had telephones tended to have more money, and those people tended to vote Republican. Another example of a poor polling practice would be to solicit feedback on customer satisfaction by leaving a stack of questionnaires at the exit. This type of example is called a volunteer or self-selected or convenience sample. The disadvantage of this polling method is that the people who would be most likely to respond to the questionnaire would be those who had a complaint. So the results would most likely show that a higher level of customer dissatisfaction than was actually the case. So if you're, let's say for example, if you're leaving a movie theater and they would like feedback on the service, so they have a stack of questionnaires at the door. Well, if you have a complaint, you're more likely to want to fill out that questionnaire. If you don't have a complaint, you may just you have other things to do with your time other than fill out questionnaires, so you may want to sort of walk right past. So anyway, that's a convenience sample. So it's hard to choose a sample, and that's one of the struggles with polling. It's very hard to get a representative sample. You're also dealing with non-response. You can, even if you randomly choose it so that everyone has an equal chance of being chosen, not everyone's going to respond, so that's another issue in trying to get a representative sample. That's one of the big challenges of polling. But anyway, so we people do the best they can, the pollsters do the best they can, but you have to sort of keep in mind some of the limitations of the polling. And that concludes this presentation.